Alright, page 1, number 1. It says given line, this symbol means line xy, and line zy intersect at point A. Which conjecture? This just means what statement? You know, which one of these is going to be okay? So which conjecture is always true? So they're looking for always. So we have xy and zy, and what they mean by that is we got xy, and we got zy, or excuse me, zw, and they intersect at point A, which means this is A. And they want to know what is always true, and they didn't give us any description on how they intersect. So I'm not going to label them all over and over again, but I mean they could look like this. Those are lines that are intersecting. They could look perfectly perpendicular. They could look like this. They could look like that. There's no way, and like this would be point A, this would be point A, this would be point A, this would be point A. So all of these situations are possible. So they want to know which one of these 4 options would work no matter what, always. So if we have xa equals ay, so for this one, we have xa is right here, ay is here. Doesn't look like they're equal, right? They would be saying like this is the exact length as this. I mean, it could be. You know, I could draw them like this, perfectly splitting this in half, but it doesn't have to be. Like this one, doesn't have to be. So that's not true. xaz is acute. It could be here, but what if it was this one? This would be obtuse. What if it was this one? It could have been a right angle. And so C is wrong for the same reason. It's always perpendicular. It could be this example, or it could be this example. It could be this example. And so the answer here is D, and what? So it says X, Y, Z, and W are non-collinear. What collinear means is that every point is on the same line. So X, Y, Z, and W. X, Y, Z, and W. I can't draw a line through X, Y, Z, and W at the same time. Same thing with like through this one. So if this is X, Y, Z, W, there's not one line that connects all of them. So non-collinear means they're not on the same line. So that would be D. For number 2, it says the figure shows lines R, N, and P intersecting. Actually, you can probably pause this and read the question. Probably save us some time here. And they want to know what information would provide that lines R and P are perpendicular. And so perpendicular means that things intersect at 90 degrees. So if R and P are perpendicular, that means if angle 6 is 90, that works. Well, maybe I should go back here. If we have 2 lines that are perpendicular, like let's say we have line 1 and we got line 2, if this is 90 degrees, that is enough information to say that all 4 angles are 90. Like if one angle is 90 degrees, they all have to be. Because think of vertical angles, which is like the angles that are across from each other. This would have to be 90. And then if these are 90, remember these are supplementary angles. So if one is 90, the other one has to be 90. Supplementary means they add up to 180. So if this is 90, this would have to be 90 to add to 180, which would mean this one is. So in order for us to have enough information, we could say like, hey, if angle 6 is 90 degrees, that means these things are perpendicular. Remember we're talking about R and P, we don't care about N. So we're looking here, oh, that one works. If 1 and 2 are 90, that would work. We don't care about angle 2 not being 90 because we're not comparing N and P being perpendicular, we're caring about R and P. There's no 1 and 2 option here though. If angle 3 is 90, I don't see that one there. Or if angle 5 plus angle 4. So those 2. Number 3, which of the following are true about the points on the number line? So we have these equations, and what I thought would be helpful is let's actually like calculate each one. So what is AB equal to? What is BC equal to? What about CD? Let's see what other options we got. We see AD here. I see BD. AB, CD, I think I have all those. Okay. So AB, 1, 2, 3, 4. BC, 1, 2, 3. CD is just 1. A to D would be 4, 5, 6, 7, 8. B to D is 1, 2, 3, 4. Alright, so AB, this one is 4. 4 plus 3 equals, AC, 1, 2, 3, 4, 5, 6, 7. Looks like AC is 7. That is true. 4 plus 3 is 7. CD is 1. AB is 5. BC is 3. That is false. CD equals 1/3 of AD. So 1/3 is the same thing as like AD, which is 8 over 3. Is 1 8/3? No. 1/2 of AB, that's 2, if AB is 4. CD, which is 1, plus BD, which is 4, 5 over 2. Does 2 equal 5 over 2? No. 1/3 of AB, so AB is 4, so divide by 3, equals CD, 1, plus 3, BC is 3, divided by 3. 4 over 3, 1 plus 3 is 4 over 3, so that is true. Let's see what we got here. Number 4. They're telling you that A, remember we go A, C, F, so you start at A, travel to C, then go to F. They're talking about this whole angle right here, so the whole entire thing is 70, this whole thing. It says, what if ACB, so this is 16. What is angle BCD? So BCD is this angle, that's the X that we're trying to find. And they give us some markings here. There's a 1 mark, double mark here, and a single mark. Remember, the like marks means they're the same. So if this is 16, this is 16. If that's X, that's X. And they all got to add up to 70. So it'd be 16 plus X plus X plus 16 equals 70. Combine like terms, 16 plus 16, 32. X plus X, 2X equals 70. Subtract 32. 2X equals 38. Divide by 2. X equals 19. The last two questions of this page are, I think, are pretty straightforward. What is the best description of acute? You know that it's less than 90. Alright, so more than 90, that's obtuse. This is also obtuse. And then this would be acute. And an angle measuring less than 0, we haven't talked too much about negative angles, and you don't really do that, but what if you had negative 100? That would be like the same looking angle as positive 100, so this would also, so less than 0 could be negative 50, which would be acute, or negative 100, negative 90. There's more than one possibility there, so this one guarantees that's acute. Last one, what is the name of an angle formed by BA and BC? Just draw, this is a ray, so draw 1 point, boom, B to A. Now I gotta draw another one. Ooh, it looks like this one starts at B again, so we're gonna start at B again. Call this one C. Remember, whenever you name angles, this could be called angle B, talking about the vertex. This could be A, B, C, or angle C, B, A. This point always has to be in the middle, so that's why it's B.